For section 3, deals with right triangle trig. In other words, the classic SOHCAHTOA. I don't care how you memorize it, but make sure you know it. Assuming you can see it eventually. There we go. So, theta is an acute angle of a right triangle. Then you have these 6 functions, or ratios more accurately. Opposite, adjacent, hypotenuse. Everybody should know what they all mean. So, if I have this situation, find the values of the 6 trig functions of theta as shown in the figure. Well, first off, what else do I need?
The other leg.
The other leg. How do I find it?
Opposite over adjacent.
A squared plus b squared equals c squared. Okay. Now, you could mess around and try to figure out theta and then use theta to find that. And that would work. Okay. Use opposite over adjacent, but that's if you know theta. So you can do a couple steps. Honestly, it's just easier to use the Pythagorean theorem. Take the legs and square them, the one you know and the one you don't. Add it to the hypotenuse squared, or set it equal to the hypotenuse squared. So you end up with x squared is equal to what? Yeah, you get 16 over here, 4 over here, subtract them, you get 12. So when you square root that, what does square root of 12 simplify to?
2 square root
2 root 3, yep. So that's what goes up here. Now when I go to do the 6 trig ratios, sine is going to be what over what? Sine's opposite over hypotenuse. So 2 over 4, which simplifies to 1/2. I don't care how you remember it. Honestly, go on Wikipedia. There's a bunch of different ways. I just remember the word SOHCAHTOA. SOHCAHTOA. If you do some mnemonic, some old hippie caught another hippie tripping on acid, whatever one you want, it'll work. Okay, there's a bunch out there. Okay, cosine of theta. Cosine's what over what?
adjacent over hypotenuse.
So in this case,
Square root of 3 over 2.
yeah, you get 2 root 3 over 4, which will simplify down to square root of 3 over 2. Okay. Now, once I have those, I can do the reciprocals fairly easily. Cosecant would be what? 2. Cosecant's the reciprocal of sine. Secant is the reciprocal of cosine, giving you, yeah, it's 2 over the square root of 3, which then you do need to rationalize. 2 square root of 3 over 2, over 3, sorry. Do anything else?
Wait, it said 6.
6, what are the other 2?
Tangent.
Tangent, cotangent. For tangent of theta, you're going to have what over what? Opposite over adjacent. In this case, square root of 3. Because you get 2 over 2 root 3, and the 2's cross off, when you rationalize 1 over the square root of 3 becomes square root of 3 over, or wait,
Square root of 3 over 2.
square root of 3 over 3, right?
Yeah.
Because remember, opposite over the adjacent, right? Okay. You were doing cotangent, which gave you what? Square root of 3. Yeah, because here you get 1 over the square root of 3, the reciprocal, which would be square root of 3. 1 over the square root of 3, you can't leave it that way. When you rationalize, you get square root of 3 over 3. All right. Everybody good on those? Okay. Now, if I'm given something like this without the triangle drawn, I don't necessarily need it. But I also want, if it doesn't specify round to the nearest decimal or say give an approximation, you need an exact answer. Okay? So if I look at this one, cotangent, secant, and cosecant of 45. Well, first off, I'm going to use the fact that 45 degrees. I do know sine and cosine for those, or at least I should. What's sine of 45 degrees? Square root of 2 over 2. What about cosine? Same thing. Yep, same thing. Tangent then, since those are the same, and tangent is just sine divided by cosine, what's tangent? 1.
That's cotangent though.
What?
It's cotangent.
Yeah, cotangent's still 1. Cotangent 45 degrees is still 1. Secant and cosecant then are also going to be the same. What are those going to be?
Two square roots
Yeah, when you so you flip it over, yep, 2 over the square root of 2, rationalize it, so times the square root of 2 top and bottom, gives you 2 root 2 over 2, but that simplifies to just square root of 2. So both of those are just square root of 2. Everybody good? Yeah.
If we ask a question like that on a quiz or test, do we have to show that work there, or could we just know what those values are?
If you just know what those values are, that's fine.
Which one?
Like the square root of 2. If you recognize that square root of 2 over 2 is here, and then you get square root of 2 here, I would honestly want you to say something like sine is equal to the square root of 2 over 2. And then if you want, you could just actually show that step. Like basically show what's there. Show the initial state of it and then what your simplified form is. You don't have to show the work of the simplification necessarily. Okay? But admittedly, something like tangent, there's no work to do. It's 1. So, what about this one? Equilateral triangle shown to find the values. Use it to find the values of tangent of 60, cotangent of 60, tangent, cotangent of 30. So for 60, for tangent, what are you going to get?
What do you got?
Tangent 60 degrees. 60 degrees is right here. Tangent's what over what? Opposite over adjacent. So in this case, square root of 3. Now based on that, what's cotangent of 60 going to be? Square root of 3 over 3. Because it's 1 over the square root of 3 when you rationalize, square root of 3 over 3. Now the other thing is, just like sine compared to cosine. Sine and cosine are considered to be complementary ratios. Okay? Because if I look at tangent of 60 compared to cotangent of 60, well, cotangent's adjacent over opposite, right? Or 30, sorry, not 60. We already did 60. If I go up here to 30 and do adjacent over opposite, what am I going to get? Square root of 3. If two ratios are complementary to each other, that means when you do complementary angles, you get the same result. Sine of 60 degrees is square root of 3 over 2. Cosine of 60 or cosine of 30 degrees is also square root of 3 over 2. They're complementary ratios. Okay? As long as you're doing it with the complementary angle, they work like that. Tangent and cotangent are that way, sine and cosine are that way, secant and cosecant are that way. So then what would the tangent of 30 degrees be? Square root of 3 over 3. Does that make sense? Complementary thing? Okay. These 6 get memorized. If you use Ohlinger's table, that's fine. If you think about the first quadrant of the unit circle and do it that way, that's fine, but make sure you know these. Okay? Using those, along with the trig identities, these are the main things you'll deal with in this section. We'll get into the unit circle more later as well. Honestly, everything but this you should already know. Sine squared plus cosine squared equals 1. That one might be a little bit less familiar, but that's just the Pythagorean theorem. These are a little bit more bizarre versions. Get these known as well. Okay? These are both 1 plus what I think of as the larger one, tangent, because it's sine over cosine, cotangent. Those I think of as the larger one are always with the 1 plus. It's going to be equal to the other one, and the two cos are together. That's literally the way I remember it. Okay? But those are also listed in the front of your book. Those are the Pythagorean identities. Okay? So if I can use those when I have oddball connections, okay? Ones that aren't as blatant. Sine to cosecant's, no big deal. Sine to cosecant's reciprocal. Sine to cosine, though, I don't have a direct relationship between them. So this is where the Pythagoreans come into play. So I'm going to use the fact that sine squared plus cosine squared is equal to 1. Well, and then cosine is given to me. So what's 0.96 squared? What do you get? Somebody, calculator. 0.9216. Subtract that, you get sine squared. It's equal to 0.0. No, 0.7. Sorry. 0.784. All right. Square root it, you get what? 0.28. Now, because we square rooted, is that positive or negative? Because square root means plus or minus, but I can't have both in this case. Why?
You can't have a negative value.
You can have a negative sign value. You can't have a negative length on a triangle, but this isn't talking about a triangle. This is just talking about those numbers.
You can't have a negative angle.
You have a negative angle.
Oh my goodness, what is it then?
It's the type of angle that says this one is.
Acute?
What's an acute angle? Not just less than 90, it's between 0 and 90, right? So between 0 and 90 puts you in what quadrant? First quadrant. And what's true about every trig ratio in the first quadrant? It's positive, so it's positive 0.28. Okay? You're right about it being positive, but you got to get justification right too. Then what would I do with that next? So we answered A. How do I do tangent of theta?
Sine over cosine.
So 0.28 over 0.96.
No, that's cosine.
Sine is 0.28, cosine is 0.96. Punch it in, you get what? Since we did 0.28 down here, I'd probably just keep it decimal, but what do you get? 0.292? It's like 0.2916 repeating, right? Yeah. Let's do another one like that. Beta is an acute angle such that tangent of beta is equal to 4. Find cotangent of beta and secant of beta. Okay, well, which one of those is easy? Cotangent. Because cotangent of beta is just going to be equal to what? 1/4, yep. Secant, though, now, do I have a direct relationship between secant and cotangent or secant and tangent? Secant and tangent. Now, that formula is 1 plus tangent squared beta is equal to secant squared beta. So when I do this, what's tangent beta? 4. Square it, you get?
16.
So I have 17 is equal to secant squared beta. So secant squared beta is equal to, secant of beta, I should say, is equal to square root of 17. Positive or negative? Positive. One more. Use a calculator to evaluate cosecant of 34 degrees, 30 minutes, 36 seconds.
What? What are you use that for?
That's how they calculate like longitude and latitude.
Are you serious?
Yeah.
That's neat.
They use degrees, minutes, and seconds. Well, how many seconds are in a minute?
That's 60.
60. So how many minutes are in a degree? 60.
60.
Why? Anybody remember? Right. You I had. Why is it 60? Why do we have 60 seconds in a minute, 60 minutes in an hour? Or in a degree? Come on, it's my normal spiel.
I'm waiting. I want to hear it from the source.
last year.
Our math system, our number system is based on what?
61.
No, our regular number system. It's called a decimal system. So it's based on what? 10. It's base 10. Binary is base 2, decimal is base 10. Base 60 is actually something called a sexagesimal system. Okay? Macedonians used it about 5000 BC or so. Okay?
Long time ago.
Our values go, the ones, tens, hundreds place all have digits from 0 to 9, right? There's 10 numbers inside of each one of those place values. Macedonians had 0 through 59 in each place value. So when you look at the problem like this, if I want to change this to our decimal system, I need to take 30 and divide it by 60. 36, though, I need to divide by 60 squared. And then just add those up. Why would you want to do that? Why would they want to use base 60 instead of base 10?
I don't know.
A few people I've had in here before that should know. Michael's not paying attention. He's just messing on his calculator. Okay.
I haven't had you before. This
I know.
completely new information to me. So.
What was it called? The basing system?
Sexagesimal.
Sexagesimal.
Yep. Base 60. It's like hexadecimals, base 16.
Sexagesimal.
Yeah, there's also a base 20 system that's Mayan.
Stop it. This is enough new stuff.
The thing is,
This is
what it comes
cool,
down to,
like the rest of the
think about the fractions in our decimal system, the fraction issue. Because remember,
There's no ones, please. Skip straight to tenths.
no.
Yeah, there is.
If you had, in our system, some things are easy. 1/2 is what is a decimal?
1.5.
1/4 is 0.25. You have terminating decimals that clean up nicely. Okay? This long ago, they didn't have a structure for those fractions, so they needed that reference point that made them a lot nicer. We have 1/3 turns into what?
0.6 repeating.
1/3?
Oh, 0.3 repeating.
0.3 repeating.
I don't care. I'm thinking 6.
1/6 is 0.6 repeating. 1/7 is 0.142856 repeating. Okay? All these repetitions cause problems when you start doing trading and commerce and those type of things. So they did a base 60 because 1/3 in base 60 is 20 over 60. It goes in evenly. Okay? It goes in 3 times. Compared to ours, which goes in that 0.33333. So they're able to do it. The only things that you run into issues, you still run into issue at 1/7, but 1/2 works, 1/3, 1/4, 1/5, 1/6. 1/7 is an issue, 1/8, 1/9, 1/10 all work, 1/11 is an issue, 1/12 works. In ours, we get these weird repeating decimal things. But when you don't even have a structure for 0 yet, which they didn't have a 0 as a number to work with, it makes it a lot easier to have that large of a base to work with, that base 60. Anyway, for this, anybody get the decimal yet?
No, I was.
Oh. 34.51.
Yeah, 34.51 degrees. And if I want to do cosecant of that, what do I do?
Oh, 1 over
1 over what? 1 over sine of that angle. Punch that into a calculator. What do you get?
Sure.
0.77? Yeah, it's like 651 or something. I would go at least 3, maybe 4 decimals. But yeah. Questions on any of it? Gesimal. Okay.